Hi all, welcome back to our digital. I'm your friend Harshit. I'm very delighted to tell you about a special course that we are bringing for our viewers. For this course, IT professionals easily give up from 25,000 to 1.5 lakhs. Yes, you heard it right. It is no less than a complete hands-on course in which our expert will take you on a journey of understanding Big Data Hadoop framework along with Spark and Scala. By the end of it, you will be confident enough to crack interview questions for Hadoop relevant job roles. So please watch the complete video to understand more about this course.
So in this session, I'm going to cover below topics: why data is required and why we have to store the data, what is the use of data, and what all are the companies that are providing big data Hadoop support, and what all are the use cases is there in big data. And in present market, big data Hadoop or Spark really good? Is there any growth for big data Hadoop or not? So these topics are today I'm going to cover in this session. So first we'll discuss about data. So why we have to store the data? So here, if we see Facebook, Twitter, YouTube, and telecom domain companies, okay. So these all are the big companies. They are generating more data. For example, if we take Facebook, so Facebook worldwide, millions of customers are there. So daily, more data is generating for Facebook. For example, you can assume I'm using Facebook. Today, maybe I will post 10 videos or 10 photos. Also, once I post, my friends will like, and same time they will give some comments, right? So these kind of data Facebook has to store. Why Facebook has to store my data? Why means after 5 years or 6 years, in case if I want to see the old data, my old data 4 years back, what exactly I posted, or 3 years back old data I want to see. At the time, compulsory if I want to see old data, compulsory Facebook has to store my data. So here problem is initially when Facebook entered into market, for Facebook company less data generated, but slowly customers increased, and now for a day almost it is generating worldwide 1,000 terabytes of data. Only Facebook company is generating per day 1,000 terabytes of data worldwide. So how Facebook will store this data? So before coming to big data Hadoop in market, earlier only RDBMS is there, but RDBMS is supporting to store only structured data. But here Facebook is generating different varieties of data. Varieties means, for example, images, and sometimes audio files, sometimes video files, and sometimes unstructured data also. Unstructured data means whenever you will post some photo, your friends will give comments, right? Maybe some smiley symbols or some comments. In comments, they will add some special characters. So this type of data will generally call as unstructured data. All this kind of data RDBMS is not supporting. So RDBMS is supporting only structured data. So that's why Big Data Hadoop came into market. So here, Big Data Hadoop will support to store any kind of data, even if it is structured or unstructured or semi-structured. It will support you to store your data in Big Data Hadoop. And here, even if you consider Twitter also similar to your Facebook, right? So Twitter also millions of customers, and per day it is generating more data. Also here SMS. So SMS also, for example, if you send your message to some other family member or friends, so telecom domain company, they have to store your data. Also here if you see telecom domain companies, generally they will store call data records also, and same time MMS messages also. MMS means multimedia messaging service. So why telecom domain companies they have to store our personal data? As for the telecom regularity rules, they have to store data. For example, if I call to someone, they will record my data. Why they have to record? Why means, as for the government rules, they have to store data in case some scenarios, okay, if any incident happened, so that time maybe court or police, generally they will ask telecom domain companies, they will ask to submit a so and so phone number related call detail records or maybe SMS records related data. That time compulsory telecom domain companies they have to provide that information, or else they will cancel that particular telecom domain company license. So if you purchase new SIM card, later if you call customer care and if you request them, I received new SIM card but my old SMS message is deleted. So if you request all old SMS messages, they will send to your mobile all those old information. So just these are the two examples I am giving. So data, each and every person life, data storage is important. Even if I'm teaching here, maybe I'm working in some software company, so I want to store data, right? For example, previous company related pay slips or maybe documents or maybe my certificates. These are required for future purpose. So compulsory I have to store my data in my personal laptop. So same way, it's not only related to social media companies or telecom domain companies, it is required in all the domains related companies nowadays. So each and every company, they have to store their data. If you go for software companies, they have to store their data. If you go for airlines companies, they have to store their data. If you go for retail domain companies, they have to store the data. Retail domain companies, they have to store data. Some people generally they will ask this question: what, sir, you are telling all the data we have to store, why retail domain companies they will store our data? Why means sometimes to grow their business they have to store our data. Why means, for example, today or maybe tomorrow some festival is coming, okay, so 1 year back you purchased some item in maybe more mega store, okay, again they are planning to give some offers coming festival. So at the time generally what they will do, they will take all the old customers related data phone numbers and they will send SMS messages. So coming Tuesday or Wednesday due to festival we are giving so and so discounts, electronics 10% off, or vegetables 5% offer, like that they will give free advertisement. So they will generally use our data for free advertisement purpose. So that's why each and every company generally they will store a data. And not only retail domain companies, if you come to insurance companies, even insurance companies, health insurance companies also they will store our data. Why means, for example, you have only 1 lakh limit to claim for a year, but already you claimed 80,000 rupees. Again suddenly if you're trying to claim another 1 lakh rupees after 10 days, so they have to check your old history, right? Whether you are eligible for 1 lakh. If you are eligible for 1 lakh, already how much you utilized for this year? So you already utilized 80,000 rupees. So compulsory, they have to store the data. Then only they will come to know, right? Already you utilized or not. That's why even health insurance companies also they will store customers' data. So nowadays, different companies, different types of varieties of data it is generating. So they are storing all kinds of data. So to store all kinds of data, existing technologies are RDBM is not supporting. That's why big data came into picture. So here, before big data Hadoop coming in our industry they faced many challenges because existing technologies not supported a high volume related data. So generally RDBMS, if you consider RDBMS, yes, it will support kilobytes, it will support. If your data is there in MBs, it will support. If your data is there in GBs, it will support. But what about terabytes and petabytes of data? If your data is there in terabytes and petabytes, your RDBMS will take more time to store the data. So that is one major problem in RDBMS. So this high volume related data issue solved by big data Hadoop. And coming to high velocity. So velocity means you have to store very fast your data near real time. For example, you've done one transaction in ATM. So that transaction immediately you have to store. So that much faster, there is no technology to store that much faster data. So here near real time or real time data we have to store. So for example, if you consider some WhatsApp, if you send a hi message immediately in live, it will reach other person. So that kind of real time and fast processing kind of technology is required. So very short time, fast processing, only big data Hadoop is supporting here. And coming to next point, variety. Existing technologies is not supporting different varieties of data like unstructured data. Yes, your RDBMS doesn't support to store unstructured data. And what about images? Yes, RDBMS supporting images. One concept is there, globes and blobs. It is supporting, but it will take more time to store that data. Which technology will support to store different varieties of data means only your big data Hadoop will support to store the data. It will allow you to store structured data, and it will allow you to store semi-structured data, and it will allow you to store unstructured data and images, videos, audio files, any kind of data your big data Hadoop supporting. Fourth point, complexity. So complexity means here see you just assume unstructured data is it will not like structured data, right? Unstructured means generally some special characters or some smiley symbols, or it is not in format, it is a completely different like a paragraph kind of. So even that kind of unstructured data also using big data Hadoop, we can align in some order, we can process and we can store in big data Hadoop. So these are the four challenges existed. So these four challenges big data Hadoop resolved. That's why nowadays most of the companies they started using big data Hadoop. Big data we already discussed about social networking related and telecom domain related, and even this health insurance related also we discussed, and retail domain related also we discussed. Okay. So coming to some facts and big data market, how big data market is growing. So 2011 worldwide it generated 7.60 US billion dollars, and coming to 2021 it is going to generate a 66.11 billion dollars. So as for industry they are expecting 2026 it is going to generate worldwide 84.69 USB billion dollars revenue. And here I'm going to give some big data examples. So why data is growing? So here left side, if you people see data initially in KBs, after that MBs, after that GBs, after that terabytes, after that petabytes. Now we are in position terabytes. Why data is growing like this? So for example, here I will give one small example. 10 years back, if you send one SMS message or one mobile pic if you take. So that time most of the people they used only VGA cameras in mobile, Nokia mobile or Samsung, small VGA cameras. So if you take one picture, it will generate that file size, that picture size, only KBs it will come. But in present generation and the current situation, each and every mobile 100 megapixel camera or 48 megapixel or 60 megapixel camera. So if you take one pic, it is coming almost to 10 MB size. And if you record one 4K video, if it is coming 1 minute recording, 1 GB file size it is coming. So that means technology is growing day by day. Same time data size also increasing day by day. So initially only SMS concept is there. So that time data size is very small size. Later they introduced the speech to text concept. So instead of messaging, you can speak and you can send audio message. Even nowadays in WhatsApp we have that feature, right? You can record and you can send. So here also data size increased. And later in mobiles, previously there is no HD video recording, but now they introduced completely HD video recording and UHD concepts and 4K video recording also. So automatically data size increased because quality increased, same time data size also increased. And the business data fits. This is any kind of business related data. And external demographics. So here external demographics means generally if you take one video of for example marriages or some engagement functions, generally photographers they will capture video, right? After that they will do some they will apply some graphics on top of that, they will add background music and they will add some uh, text quotations. Okay, so automatically there also size increasing. And coming to next, GPS coordinates. So if you consider Ola Uber cabs, they are using GPS system. So for Ola Uber also for day it is generating more data. How it is generating? For example, if you take cab from one location to another location, okay, so it will calculate. First, it will take your phone number, user data, how many kilometers you traveled, how much amount you paid, whether you paid via some UPI or you hand over the cash, total how much bill generated, complete all the information, even driver related details also it will capture in our system. So in GPS system also it is generating data. So for Ola company, not only single cab, right? Each and every big city almost if you consider Hyderabad, more than 500 cabs are running only for Ola company. And Uber, if you consider Bangalore, almost 700 cabs are running. So all the 700 cabs related data daily, maybe multiple trips, one location to another location, from there again another location. So all this information, this kind of data they have to store for recording purpose or future purpose. So that's why even wherever GPS system is that there also it is generating more data. And the social interactions. So social interactions we already discussed, right? Like a WhatsApp chat related data or Facebook chat or maybe your MS Teams related data. So not only this, earlier people used R code and Twitter, nowadays Twitter. So all social networking sites, there are also more data it is generating. So that data also they have to store. And user generated data. So in case if you generated your own data, so that data also we have to store. So left side data initially in KBs, after that MBs and GBs. Now situation is in terabytes. In future maybe petabytes also it will generate. Okay, and right side I given reasons. So technology increased. So initially SMS concept, later they introduced speech to text, and again later they introduced full HD video and good quality images, and GPS system and social networking systems. Now more customers, that's why more data in social networking. So these are the reasons, and at the same time these are the examples for big data. And coming to Hadoop, so here why elephant symbol and why Hadoop? Who kept this name as Hadoop? Why elephant symbol? Initially big data Hadoop implemented by dog cutting. So he is the guy who implemented big data Hadoop. Earlier he worked in one multinational company. After that, due to some issues with management, he left from organization. Almost 2 years he spent in home, and finally he implemented his own big data Hadoop. When he was implemented big data Hadoop, that time he was a kid. That kid, 2 years old kid. So daily that kid was playing with a toy. So the toy is this elephant symbol. So that is the one reason to kept this elephant symbol. And another reason, this technology basically to store large data, big data files. So elephant also looks like bigger. So due to these two reasons, he kept that elephant symbol. And why he kept name as a Hadoop? Why means that kid, whenever he was playing with the toy, so the toy nickname is Hadoop. So daily kid will call Hadoop, Hadoop, Hadoop. That's why he kept for this technology name as Hadoop. Okay, so this is the meaning why he kept Hadoop and why elephant symbol in front of Hadoop. Also, basically, this is open source technology. Big data Hadoop is completely open source technology. So later, this guy hand over this big data Hadoop technology to Apache Software company. So now big data Hadoop is from which company means Apache Software company. And what are the advantages? How big data files big data Hadoop will handle? It will handle if your data is in terabytes and petabytes also it will handle. Even if it is a structured or unstructured or any varieties of data, Hadoop is supporting on commodity hardware. So commodity means cheap quality hardware also you can store your data. You no need to use supercomputers for storing your data. You no need to use supercomputers. You can store your data on cheap quality hardware machines also. So your big data would be supporting, and it will support to read and write operations and also high performance. How it will give high performance? Because here completely distributed your data, it will distribute. Maybe later classes I will give more explanation about how it will distribute. So compared to other technologies to store your data, here it will give high performance. Here which technology is more growth? If you see here servers, so servers overall growth between 2010 to 2015, any kind of server, it is Apache Tomcat or Java server, whatever, 27.3%. And storage, data storage, 61.4%. And networking, any networking, 42.4%. Softwares, in market we have different softwares, right? 34.2% growth. Services, 39.5%. So which one has more growth though? Data storage. So data storage 61.4% growth. How your data will generally store in Hadoop servers? In real time, here we are seeing this is server room in a Yahoo company. So in this server room, Here we are seeing some racks, rack 1, rack 2, rack 3, and number of racks available. So inside each rack we are seeing some disks, right? Here small disks. So in real time, whatever data Yahoo company is generating, all the data it will store inside this hard disks. So for example, you logged in a Yahoo mail, you sent one mail to your friend. So sent items it will show you that body and content too, right? So that all the information in real time it will store inside this racks and inside this hard disk. In real time, big data Hadoop related all the data it will store generally in server rooms like this only. This is just one example how in real time data will store. Understanding about big data. So till now few topics I covered and I will see remaining topics now. And BI tools related already we discussed, and BI related tools also not supporting high volume related data, and different varieties of data also not supporting. Also velocity also different like fast performance related also existing design or architecture not supporting in BI tools. Also it is very expensive to handle complexity related data. So these are the some challenges existed in BI tools also. Those challenges are resolved by big data Hadoop. And what are the advantages is there in big data Hadoop? So one is this is completely Java based framework. So big data framework implemented by using a Java code. So that is completely they implemented using Java code. Also, it is supporting structured, unstructured, and semi-structured data, and it will allow you to process large data sets or large data files. And completely big data Hadoop is open source technology. Also, can handle rapidly changing the data. See, can handle rapidly changing the data means, for example, one person is processing structured data, another person processing unstructured data, and one more person processing semi-structured data. Even multiple different varieties of data, structured, semi-structured, unstructured, continuously, if it is coming also, your big data Hadoop will store your data, any varieties of data, any kind of data, it will allow you to store. Hadoop uses not only the storage, so big data Hadoop not only for storage purpose, okay, even Hadoop having processing capability also, not only data storage, it is having processing capability also. Also, Hadoop framework are scalable and fault tolerant. So scalable means, for example, uh, you have only 1 TB storage limit. So maybe that storage is going to full tomorrow. So yes, if it is going to full also, you can buy 1 more TB and you can add into existing cluster. So you can increase that capacity or you can add more capacity or more storage. So that is called scalable. Increasing or decreasing is called as scalable. And fault tolerant. Fault tolerant means you stored your data in one server. Okay, maybe that server is crashed. What about backup? How about your data? So here each and every data it will store in three different servers, three different places. In case if one place, one location, that particular cluster or server is down also, your data it will read or it will retrieve from different location server. That is called fault tolerant. And also Hadoop enables you to process petabytes of data also. Okay, but in at present in most of the companies only till terabytes it is generating. Maybe in future if it will generate petabytes also, your big data Hadoop will support. And also evaluation of Hadoop. So here three things we should know. One is hardware, second one is data, and third one is software. Hardware related mainly 40 years back, it is very expensive, right? So even not only 40 years back, 15 years back, if you want to buy one laptop, okay, just 2 GB RAM and some 250 GB hard disk, 40,000, 50,000 rupees. But now same 50,000 rupees you will get 8 GB RAM and 500 GB hard disk. So now technology improved and some competition is there between all the manufacturing companies. That's why prices also reduced now. Also coming to second point, data. So data is very important nowadays. So each and every company they have to store data and it is very valuable. And coming to software, here two things. Mainly coming to big data, we have different models. HDFS basically to store your data, and for processing capability, MapReduce model. A little more about Hadoop. So Hadoop is completely open source project and it is from Apache software company. And basically Hadoop is a framework. So what is framework here? Even we heard right Java also some framework, Spring framework, Hibernate, and different frameworks. What is framework here? Generally, framework means some built-in code, built-in functions, or built-in functionality. 50% code it will come with your software, and based on that remaining 50% we have to implement. That is called a framework. They will define some built-in functions. For that built-in functions, we have to pass our parameters so that it will give results. That is called framework. So Hadoop is a framework here. Basically, here we have two important concepts. One is HDFS. HDFS means a Hadoop Distributed File System, and the second point is MapReduce. So HDFS basically it will allow you to store the data. A set of machines running HDFS and MapReduce is known as a Hadoop cluster. Even in one cluster, if it is single node or multiple nodes also generally will call as cluster. Cluster means single or more number of machines. In one server room, you can keep one rack or multiple racks. Each rack contains some nodes. Each node will store some data, whether it is 5 terabytes or 1 terabyte, whatever. Also, HDFS allow you to store data. Basically, to store data back they implemented a Google file system GFS. Based on Google file system, they implemented a Hadoop distributed file system. Based on Google file system, they implemented a Hadoop distributed file system. So basically HDFS, you, you can store your data one time and you can read n number of times. Also MapReduce, it is just allow you to process your data and it will allow you to store inside HDFS. So on top of HDFS, they implemented a MapReduce model. So Hadoop can run MapReduce programs written in various languages such as Java, Ruby, Python, and C++. But usually Java is preferred. Why Java is preferred means they implemented Big Data Hadoop using Java framework. That's why by default Java is preferred. Also here we have some examples of big data that already we discussed, and what is big data or Hadoop? So Hadoop we discussed it is a open source framework and it is came from Apache software company, and it is allow you to write a large amount of data. Also it will allow you to store your data in large clusters which could have thousands of computers on the clusters. So coming to examples of big data, we already discussed. So Facebook is generating 500 plus terabytes of data per day, and also New York Stock Exchange also it is generating 1 terabyte of data per day. Even Jet Airlines also collecting 10 terabytes of data every 30 minutes. Why Jet Airlines collecting that much data? See, Jet Airlines they have multiple flights, right? So peak hours, maybe Bangalore to Hyderabad, Hyderabad to Chennai, Chennai to Mumbai, or Mumbai to US. So many flights, apparently many flights will run. So each and every flight they have to store customers data, right? Which customer is traveling to which location, onboarded. Okay, so whether for him in flight they provided breakfast or not, what kind of ID proof he submitted. So everything they will capture. So that's why it is generating 10 terabytes of data. And characteristics of big data. So high volume, high velocity, variety. So Hadoop is supporting to process high volume related data. And velocity. Velocity basically to analyzing the records, identifying the reason for losses. For example, you consider one retail company is there, maybe Big Bazaar. One customer purchased maybe one item. He paid 600 rupees. So generally, all the cashiers, end of the day after 9 o'clock or 10 o'clock before closing the store, they will give updates about transaction details and the cash they will hand over to store manager, right? So that store manager he will calculate. In case one item 600 rupees it is showing, but the actual price 650 rupees. So generally what they will do analysis why that 50 rupees mismatch happened, whether that is cashier miss or cashier problem, or maybe on top of that item instead of 650 rupees price tag, by mistake they tagged a 600 rupees. So these kind of analysis they will do. So reason for losses, they will do this kind of analysis. So next time they will generally to to resolve these kind of issues. Next time they will conduct a meeting with all the cashiers. So you people are doing these kind of mistakes. So due to these mistakes, we are getting losses. So based on these guidelines, next time they will not repeat, so that slowly this kind of losses it will reduce. So velocity basically to do analysis for business losses and varieties. Varieties already we discussed. Your Hadoop will support any kind of data. And a brief overview of Hadoop history. So initially 2002, dog cutting created an open source. After that 2004, Google published MapReduce based on a GFS papers. GFS means Google File System. In 2006, dog cutting developed the open source project, and initially only MapReduce and HDFS, only these two models came into market. So HDFS it will store your data and MapReduce processing capability. In 2008, Yahoo company they did one setup in a cluster room. They installed 4,000 machines, 4,000 nodes, and they tested that it is supporting to store data in all 4,000 nodes, and same time it is giving fast performance or not. That kind of testing they done. After that, successfully it, it is reached benchmark within sort of time. After that, slowly most of the big data companies they started using big data Hadoop from 2009 onwards. So in 2009, again Facebook launched a SQL support related module, that is Apache Hive module. So Facebook company implemented one Hive module in Big Data Hadoop. So Hive module generally it will allow you to process semi-structured data. And what are the domain companies they are using a Big Data Hadoop? Social networking companies, airlines companies, banking domain companies, e-commerce, mailing, telecom domain, retail domain, healthcare domain related companies also. So nowadays there are many domain companies, but here I specified only few domain related companies. And coming to companies that are using. So earlier only 50% companies used big data Hadoop, but now almost 90% companies they are using big data Hadoop. So these are the main companies I just specified for your reference. Also here these are the different components in big data Hadoop. One is a HDFS, your data storage purpose. On top of HDFS, these are the modules implemented: HBase, MapReduce, Hive, Pig, Scoop, OG, U. This is about big data introduction. So what is a HDFS here? So HDFS means basically Hadoop distributed distributed file system. So what is the meaning of this Hadoop distributed file system? So distributed means your data or your data files, it will distribute to different systems. So it will not store in a single system. It will distribute to different systems. So file means generally in big data Hadoop, your data it will store in a file format. Backend always it will store in a file format. So system means here our data generally it will store in hard disks or machines or nodes. Okay, so all these three same meaning only: system or node or machine. Okay, so HDFS means Hadoop distributed file system. So in HDFS, now we'll discuss about Hadoop architecture. Okay, so first we'll discuss about Hadoop 1x architecture. Okay, so in the Hadoop 1x architecture, we have few drawbacks in Hadoop 1x architecture. Okay, so I will explain now what are the advantages in Hadoop 1x architecture and what are the disadvantages is there in Hadoop architecture, because initially when Apache Software Company released Big Data Hadoop in market, most of the companies they haven't used Big Data Hadoop technology because initial version, okay, in 1x version, few drawbacks they were found. That's why they didn't use the big data Hadoop technology. But in a later, they they released the upgraded version, that is a Hadoop 2x. So what other drawbacks is there in 1x? All those drawbacks they resolved in Hadoop 2x version. After that, slowly most of the companies they started using this big data Hadoop technology. Okay, so now I will explain about Hadoop 1x architecture. You can assume here one user is there. Okay, so he is the user. You can just assume he is the user or I am the user. Maybe if I am trying to store my data, then I am the user. Or if you are trying to store the data, then you are the user. Okay, so now this user having some data file. So here maybe you can assume a data file name customer.txt. So this data file size you can assume 100 MB. This user having one data file, that data file name is customer.txt, and this data file size we are assuming 100 MB. Generally in the real time data file size will get like GBs, terabytes or petabytes. But here, just for better understanding, I assumed data file size as 100 MB. Okay, so now this user want to store his data inside Hadoop. So how it will store that particular customer.txt file. Okay, so to store this data, so whom this particular user has to contact. Okay, so here I have one more node. Okay, that node name is name node. Okay, so here this is the name node. Okay, so what is the purpose of this name node? Why we need a name node? Okay, so here generally this name node it will work like a manager for entire Hadoop architecture. So who is the manager for Hadoop architecture means name node is the manager for Hadoop architecture. Okay, so what it will do? So generally it will store metadata it will store. So where it will store is it will store inside hard disk or RAM memory. So it will always store metadata inside RAM memory. Okay, so what is metadata here? Okay, so generally metadata means here we have file, right, customer.txt. Okay, so that particular file name it will store, the file size also it will store, and file is in which location, that particular location or path also it will store, and user requested to store the data, so that particular username also it will store inside metadata. Also here which date that particular user requested to store the data, also timestamp, so exactly which hour and which minute which second that particular data file stored. Okay, not only this, here block id also it will store, and a block size also it will store. So what is block id and block size? For example, in our laptop generally we'll store our data, right? So where it will store? Inside hard disk it will store. So hard disk means a small chip, right? Okay, so that chip contains some storage capacity, whether 1 terabyte or 2 terabytes. Okay, so inside that chip small blocks available, each block having some storage capacity. Okay, whether that is a 64 MB or 1 GB, whatever. Okay, so that particular block id also, that information also here it will store, and the block size also, each block storage related capacity also it will store here. Okay, so all these generally will call metadata. Okay, metadata. So this information will call metadata. This metadata inside name node, inside RAM memory it will store. Okay, not in hard disk. So why it will store only in RAM memory? Why not in a hard disk? Okay, generally this name node has to interact with multiple users in real time or live. Okay, because now one user requested, parallelly maybe n number of users will request or n number of users will connect with the name node. So for each and every user parallelly name node has to give response. So if parallelly in very fast it has to respond means compulsory name node has to store this metadata in the RAM memory. To read data from RAM or to read data from hard disk, which one will be more faster means only RAM memory. Data reading from where it will be fast means only if you read data from RAM memory, then only it will be fast. Hard disk means it will take time. Okay, so that's why here always name node they will use high-end configuration machines. Okay, because it has to interact with multiple users or multiple nodes same time. High-end more RAM also they will use here. More RAM is required because to store metadata. Okay, so this is about metadata and name node. Now this particular user will connect name node. Okay, hi name node, I have one data file, I want to store my data, could you please allocate me some space so that I can store my data? Okay, now name node is received request from user. Okay, so in that situation, compulsory name node has to give response back to user. Okay, so now what name node will do? Okay, so before going to response, we'll discuss about some other node. Okay, so here I am assuming I have data nodes, some data nodes. Okay, maybe I have three data nodes. Okay, in real time, maybe n number of data nodes or thousands of data nodes or thousands of systems or thousands of machines. Okay, so first one I'm just calling as data node 1, and second node I'm just calling as data node 2, and third one I'm calling as a data node 3. Okay, so now I have total 3 data nodes. Okay, so what is the purpose of this data nodes? Okay, your actual data, so your customer.txt file contains some data, some content, or maybe some data. Okay, so that the entire data and the entire content, where exactly it will store, means inside data nodes. Only data nodes having a storage capability, name node having only metadata storage capacity. Okay, but the actual data always it will store inside data nodes. Okay, so in real time n number of data nodes they will use based on a project requirement. Okay, so each data node capacity may be 1 terabyte or 10 terabytes. Okay, that is based on requirement. Okay, so now here each data node contains again some blocks. Okay, because each block it will store some piece of data. Okay, here I am assuming total 3 blocks available in each data node. Okay, so even my data node 2 also 3 blocks, and also data node 3 also 3 blocks. Okay, so here first one I'm treating as B1 block, and the second one I'm treating as B2 block, and the third one I'm treating as B3 block. Okay, so same way here also uh, B1 block, and here also B2 block, and here also B3 block. So like that, if you have n number of missions, each mission n number of blocks. Okay, in real time n number of blocks. But here I am just assuming each data node I have only 3 blocks. Okay, now you can assume this is completely new cluster. This cluster, all the data nodes and all the blocks, completely space is free, completely entire space is free. Now who is having this information? Okay, so which data node contains space is free, and which data node completely occupied. So that particular information only name node should contains. Okay, so what other data nodes is full, what other data nodes is space is available, that information only name node having, because name node is the manager for entire Hadoop architecture. Okay, now this name node has to give response back to user, right? Because user requested for storing the data, so name node has to allocate some blocks. Okay, so here just I'm assuming, so randomly generally name node will pick up data nodes and blocks. Okay, randomly it will pick up. So here data node 1, it is assigned b1 block, data node 1 b1 block, it is assigned. So here 64 MB data we can store, and again we can assume randomly data node 3, here maybe you can assume b3 block assigned, and 36 MB we have to store. Okay, so name node now giving a response back to user. Okay, for you I assign total 2 blocks. Okay, how many blocks? Total 2 blocks. one block inside data node 1 b1 block and another block that is inside data node 3. So you can go and you can store your data like that name node given response back to user. Okay, and here maybe few people they will get confused. Why 64 MB in b1 block and 36 MB in a different block? Okay, Hadoop 1x architecture, each block default storage size 64 MB. Each block default storage size 64 MB. That's why name node allocated two blocks because this data file 100 MB. So for to store 100 MB data, how many blocks is required? Two blocks required. In real time, not 100 MB, terabytes. Okay, if it is terabyte means n number of nodes and n number of blocks it will assign. Okay, so now what user will do because user got response. Okay, so here I have one more node that is called a job tracker. So what is the purpose of job tracker here? Okay, so generally job tracker having a processing capabilities. Okay, so in entire Hadoop architecture, who is having a processing capabilities means only job tracker having a processing capabilities. That's why when you want to store your data, you have to contact job tracker. Again, whenever you want to retrieve your data, compulsory you have to contact the job tracker. So via job tracker only we have to read our data or we have to store our data. Okay. Now this particular user will contact job tracker. Okay. Hi job tracker, for me name node assigned so and so a data nodes and so on so blocks. Could you please help me to store my data? So this is the request I got from user. Okay. Now what job tracker will do? So job tracker again it will contact the name node. Okay. Hi name node. So and so user requesting me to uh, process data. So could you please let me know? Can I proceed or can I wait? Okay, so based on that, here again, name node will give a response back to a job tracker. Okay, you can proceed whatever user requested, that is correct. Then now what job tracker will do? Okay, so here now job tracker will split your data file. So who will split your data file means only job tracker. So Hadoop framework will split your data file. Okay, so your data file name is customer.txt. Inside that some content is there, but here it will split. Okay, so split one 64 MB data it will. So 60 first split 64 MB data, split to two remaining data 36 MB. Okay, if it is 200 MB means how many splits? Four splits. So by default name node will assign four blocks because each block storage capacity 64 MB. Okay, so these split one split two. Okay, now it has to process. Okay, so before discussing about the processing concept, here I have one task tracker. Okay, so generally each and every data node contains one task tracker. Each and every data node contains a task tracker. Okay, so what is the purpose of this task tracker? Okay, what is the purpose of this task tracker? Okay, so generally task tracker, whatever job tracker will assign work to task tracker, that task tracker it will execute and it has to complete that work, and again it has to give response back to job tracker. Like for example, you can treat job tracker is the a lead for task tracker. And generally in real time what we'll do in software companies, okay, so lead will assign some work to developers, right? Okay. Again, end of the day or maybe next day status call, all the developers they have to give status update like that particular task is completed or it is in progress or he is unable to do. Okay, this kind of progress developer has to give lead, right? Okay, so here also same. Job tracker will assign tasks to the task tracker. Task tracker has to complete that work and then again it has to give progress report back to job tracker. Okay, if it is successfully completed, then successful information it will send. If it is failure information it will fast, and it will in progress means in progress information it will send to a job tracker. Okay, so this is about the task tracker. So task tracker is not separate node. Data node, each data node is separate nodes. Each data node contains task trackers. So task tracker is a small kind of Java process. Okay, inside that machine itself, one small process will run, that is called a task tracker. Okay, now this job tracker parallelly split to one, it will send to data node 1, and split two related data, it will send to this task tracker, because here nodes, so inside data node 1, data node 3 only it is allocated, so parallelly distributed. So your data file is very large also, terabytes, petabytes also. Hadoop framework, it will split into small chunks. Those n number of chunks or n number of small files parallelly it will distribute to multiple systems. So parallelly it will execute all your data files and it will store inside Hadoop. Okay, so here also job tracker, first split it sent to task tracker, and second split it sent to another task tracker. Okay, so inside data node 1, b1 block it is assigned, right? So here half of the data 64 MB it will store here, and remaining uh, 36 MB inside B3 block data node 3, right? So here 36 MB it will store. So parallelly both the task trackers will execute and it will store the data inside the task trackers. Okay, now, okay, sir, you said each block size 64 MB, but here you stored only 36 MB. What about the remaining space? Okay, in a Hadoop 1x architecture, once you store some data, it is less than 64 MB, like 30 MB or 40 MB. Once you store some data file, remaining space completely it will be waste. It is not possible to store another data file in same block. So this is one a drawback in Hadoop 1x architecture. Okay, so remaining space completely it will be waste. So your block size is 64 MB, but you stored 1 MB data file. So that means remaining 63 MB it will be waste. Okay, so this is drawback in 1x architecture, but in 2x they resolved that issue. How task tracker will give status updates to job tracker? Okay, because job tracker assigned one task to task tracker. So that task tracker executed and it is stored data inside B1 block. Okay, but after storing data into B1 block, task tracker has to give updates back to job tracker, right? So how it will give updates back to job tracker? Okay, so here we have one concept, okay, that is progress report. Okay, so how task tracker will send a progress report to a job tracker? Okay, so here task tracker to job tracker. Okay, so basically in a Hadoop 1x architecture we have heartbeat signal concept. Okay, so generally every 3 seconds each and every task tracker will send heartbeat signals to job tracker. By default, every 3 seconds, task tracker, parallelly all the task trackers, each and every task tracker will send heartbeat signals to the job tracker. So what is the use of this heartbeat signals? Okay, so first point every 3 seconds, but second point, what is the use? Okay, so use means if task tracker is sending heartbeat signals to job tracker, that means this particular job tracker will assume that this task tracker is alive. Okay, if it is continuously sending status to job tracker means then job tracker will consider task tracker is alive or not. Okay, if it is continuously sending, then job tracker will assume, okay, this is alive, this task tracker is working with a good health condition and it is alive. Now for example, this task tracker 3 seconds happen, so heartbeat signal not sent to job tracker, you can assume, and again after 3 seconds also it is not sent. Then how job tracker will consider this task tracker is not alive or not with a good health condition? So job tracker will wait till 10 attempts. 10 attempts means each attempt 3 seconds, right? So till 30 seconds job tracker will wait. Even 30th second or 10th attempt also task tracker not sending any heartbeat signal to job tracker means then this job tracker will consider this particular task tracker is crashed or not with good health condition. Okay, then further tasks it will assign to different task trackers. So job tracker is assuming this task tracker is dead or crashed, so whatever further tasks will be available, those tasks it will assign to other task trackers because this task tracker is not working, first task tracker is not working. Okay, so this is about your second point. Okay, and third point, progress report. Okay, progress report. Okay, so job tracker assigned one task to task tracker. So task tracker has to execute that job and it has to store data inside block, right? So once that task is executed, then task tracker will send a status to job tracker via same heartbeat signals. Every 10th attempt, every 10th attempt, it will send a progress report to job tracker. That means every 30th second, it will send a progress report to job tracker. Okay, so and so task is successful. If successful means successful information it will send to job tracker, or still it is in progress means in progress status like 30% completed, 30% in progress, or 40% in progress, or 70% in progress. So that information via heartbeat signal only every 30th second it will send to job tracker. Even if it is failed also, failure information, if it is failed also, failure information, this particular task tracker will send to a job tracker. So this is the use of heartbeat signals. Okay, so make sure that these 3 points very important. Okay, only these 3 points, due to these 3 points only job tracker will come to know task tracker work related progress or task status. Okay, so first point, every 3 seconds heartbeat signals it has to send to job tracker. If it is continuously sending means then job tracker will consider that okay, this particular task tracker is alive. If it is not sending means it will wait till 10 attempts. Even 10th attempt also, if task tracker didn't send any heartbeat signal means then job tracker will consider task tracker is dead or crashed. And the third point, every 10th attempt task tracker has to send a progress report to task job tracker. Okay, progress report to job tracker. Okay, so now job tracker got a response back from each and every task tracker, and then same job tracker will give update to user. Okay, whatever task you requested that is executed successfully. But now my doubt is, here we have 3 data nodes. Data node 1 3 blocks, but one block is full. Data node 3 we have 3 blocks, but third block is full. So how name node will come to know these 2 blocks is full? Because name node should have that particular information, or else if different user will request again name node, right? I have one data file, I want to store my data, could you please assign some blocks? But name node should know, right, what are the blocks is already full and what other blocks or space is available. That information up to date name node should have that information. So now how name node will come to know this particular block is full or not. Here also each and every data node it will send heartbeat signals to name node. Each and every data node will send heartbeat signals to the name node. So what is the purpose? What is the purpose? Okay. So now again a heartbeat signals concept only, but a heartbeat signals between data nodes to name node. Earlier task tracker to job tracker, but now heartbeat signals concept between data nodes to name node. Okay. So here also every 3 seconds, this is by default 3 seconds. Okay, by default 3 seconds, every 3 seconds each and every data node will send a heartbeat signals to name node. That means name node will consider, okay, this particular data node is alive. If it is sending continuously heartbeat signals to name node means then name node is considering that particular data node is alive. Okay, in case if this data node is not sending heartbeat signals to name node, then it will wait 10 attempts. Even if 10th attempt also data node didn't send any heartbeat signals to name node means then this name node will consider this particular data node is crashed or not with a good health condition. Then what name node will do? Then further user requests, the name node will consider to assign blocks to only data node 2 and data node 3 because this data node is not responding. This is crashed or maybe not with good health condition. Okay, and now here it will send block level report also. Block level report means data node has to give updates to name node. What other blocks, how many blocks are there, what other blocks is full, what other blocks or space is available. So while sending heartbeat signals to name node every 10th attempt, each and every data node will send a block level report to name node. Okay, so I have 3 blocks. B1 block is full and B2, B3 block space is available. So this information data node will send to name node. Then name node will update inside metadata. So data node 1 only 2 blocks available. That information it will capture. Even B1 block also full. That also it will capture. Okay, whenever some other user will request, then name node will consider only B2 and B3 blocks because only B2 and B3 space is available. And same time this data node also parallelly it will send heartbeat signals to name node. So here also B3 block full means 36 MB. Okay, and the remaining space it is not possible to use for other data file because remaining space completely it will be waste. So this data node also it will give update only B1 and B2 block space is available. So all this block level information each and every data node via heartbeat signals it will give updates to name node so that the name node will update metadata. Okay, so this is how name node and job tracker getting updates from data node and the task tracker. Okay, now I have one doubt. So this particular data node you can assume crashed or not responding, but here user trying to read the data, maybe user executed one query, read query, select star from employee or select star from customer. Then how it will read the data, how it will read, because this this particular data node itself crashed, that machine itself not working. Then what is the backup? Okay, so Coming to backup now, generally in Big Data Hadoop, each and every piece of data, it will replicate in three places. Okay, now we'll discuss about the factor replication factor. Okay, so replication factor, by default your data in Big Data Hadoop, three different places it will replicate. That means you can assume same data, maybe same data, it will be replicate in maybe another block. Okay, so same data now you can assume here also available 64 MB, and same data it will replicate here also. So that means here also 64 MB available. Okay, so now you have backup, right? If first data node 1 goes down, name node have information that same copy of data it will be available in data node 2 and data node 3. So from here it will read another copy of data and it will show to user. So this is what about the replication factor. If one copy not available, other replication copies related data available in Hadoop cluster, from there it will read your data. So even now data node 1 is crashed, maybe third also crashed, but still data node 2, inside data node 2 one more copy available. Okay, so by default replication factor, by default three copies of data it will store, but you can increase replication factor, you can increase or you can decrease also. Okay, you can decrease also. So if your data file size is 100 MB, with replication how much space is required? 300 MB, because replication factor 3 means 300 MB. Okay, if it is 10 terabytes means 30 terabytes of space is available. So replication factor by default 3, but you can increase or you can decrease. Okay, if you want you can make it only 2 replication factor, that means only 2 copies it will store. Or if you want 10 copies, each piece of data, if you want 10 copies, you can specify that also. That is basically configuration where they will do this replication factor configuration. Means in backend we have one data file HDFS-site.xml file. Inside that XML file, basically Hadoop admin team they will do configuration like heartbeat signals configuration, and the same time they will do a replication factor configuration also. Okay. See, by default here every 3 seconds, and here also by default of 3. In case if they don't want 3 means they will in configuration file they will make it a 5, or maybe they will change it to 2. Okay, here also instead of every 3 seconds they can make 10 seconds, or maybe they can make 2 seconds. It is based on maybe a traffic or maybe a project or requirement that is configurable. If you don't want to configure, by default it will consider only 3 seconds and replication factor 3 copies. Okay, so this is about backup or replication factor. Now you can assume all these nodes are there in only one location and one server. So if you keep your data center in only one location and one server, if that particular server or location maybe something happened, means your entire cluster will be down. At that time data backup not available, and even you are unable to access. So that's why in real time, generally what they will do, they will maintain multiple servers or multiple clusters, like maybe in India one location, okay, maybe Bangalore one data center they will maintain, or maybe some different location US you can assume another data center. Okay, so whenever name node will assign blocks to user, what it will do, nearest data center two copies, okay, nearest data center two copies it will assign two replication factor, but the longest distance server, maybe in a US server, it will assign a third replication factor related block. That means you can assume data node 1, data node 2, you can assume that only these two nodes in India server, these two missions. But the third mission or third data node, it is available in USA. So if India server is completely down also, data available backup in USA server. So from there it will read. Whenever user trying to read the data, then it will read from USA server and it will show. That's why most of the multinational companies, they will maintain data centers in different locations, because if one location, if one server goes down or crashed also, data backup will be available from other location. Okay, so same way even here, this 36 MB size also it will replicate in uh, different nodes. So to replicate also here, okay, basically 36 MB, okay, 36 MB. So same, this also third replication, okay, third replication required, okay. So here third replication, here also 36 MB, okay. So whenever name node will give response back to user for space allocation, name node will assign blocks with replication. Okay, initially we discussed like here only two blocks, right? So basically if I tell about a replication starting itself, you people will confuse. That's why generally if your data file size is 100 MB means how many blocks required? 64 MB one block, 36 MB two blocks. That means total two blocks with replication. With replication, how many is required? 2 into 3 replication factor. Total 6 blocks it will assign. Your name node with the replication factor, 6 blocks it will allocate. So user can contact job tracker. These are the 6 blocks for me assigned. So that job tracker will help to store the data, same data in 6 different blocks. So this is about replication factor. Okay, so if one data node goes down, we have backup another data node, or maybe from different location server or different data center it will read. But my doubt is, if a job tracker system or node goes down, what is the backup? Okay, so then there is no backup. Okay, so here 1x disadvantages or drawbacks. Okay, drawbacks. So first point, space wastage. This already we discussed, right? Out of 64 MB block storage space, if you store only 36 MB, remaining space will be waste. And the second point, if job tracker goes down, again we have to wait till job tracker is up. There is no alternative. No one will do job tracker work here. Single job tracker, only job tracker having processing capabilities. to read your data or to store your data, compulsory each and every user compulsory has to contact only job tracker. So there is no backup for job tracker. If job tracker goes down means we have to wait till it is up. We don't know when Hadoop admin team will make it up. Maybe if this particular job tracker, if some power supply or some repair means they will do immediately within half an hour or one hour. Maybe they need completely, maybe that particular machine or node is crashed means again they have to replace, right? So they have to buy that particular node or system or hard disk. It will take time, right? So we don't know within half an hour or 2 or 3 days. So that till it is up we have to wait. That is one major drawback in Hadoop 1x architecture. Okay, now if name node goes down, what is the backup? Without name node it is not possible to contact data nodes, or even for retrieval also it is not possible. Data retrieval also not possible and data storage also not possible, because to read your data or to store your data, user or job tracker compulsory has to contact name node only, because name node has to give information. Your data stored in so and so data center and so inside so and so data node and so and so block. So that information only name node is having, because name node is the boss for entire Hadoop architecture. So now this name node goes down means there is no alternative or backup. If name node goes down, here I have one FS image. Here I have one FS image, and you can assume here I have one more node, that is secondary name node. Okay, now I will explain about FS image and secondary name node. What is the purpose of FS image and secondary name node? First we'll discuss about FS image. Okay, this FS image, what it will do generally, each and every data node will send progress block level report to name node, right? Every 30th second. Okay, that means every 30th second name node is updating metadata, always latest metadata. Okay, so whatever metadata, latest metadata, generally it will come, it will be same, it will be available in FS image also for backup purpose. Okay, so it will keep that every 30 minutes till 30th minutes FS image will keep metadata backup, and it will send to secondary name node. So that means FS image always latest metadata, it will keep till 30th minutes. After that it will move to secondary name node. Again next 30 minutes whatever latest uh, block level report or metadata it will update in name node. Again it will keep next 30 minutes, it will keep latest metadata in FS image. Again it will send to secondary name node. So secondary name node is backup for name node, only metadata backup. Okay, just please note down this point. Okay, only metadata backup. That means if your name node goes down means your say secondary name node will not work like name node. That capabilities secondary name node doesn't have. Only metadata will be available backup in secondary name node, but secondary name node will not act like name node. So if name node goes down means we have to wait till it is up. Then what is the use of secondary name node? Why secondary name node is required here? That means in case if this name node completely crashed, Hadoop admin team, you can assume they replaced with a new mission or new node. Generally what they will do, first they have to install Linux operating system. On top of that they have to install HDFS Hadoop softwares. Once the system is ready, then entire metadata they will copy from secondary name node to new name node. They will make new name node up. So once name node is up, then entire old metadata like which user related data is there in which data node or which block or which data center, that information again new name node having, right? Because secondary name node having always latest metadata and old metadata also. That entire metadata Hadoop admin team they will copy into new name node. Then new name node will work like your old name node. Only that is the purpose secondary name node available. But till name node, new name node is ready, everyone has to wait. So this also one major drawback in Hadoop 1x architecture. So this is about Hadoop 1x architecture. Okay, and next session we'll discuss about Hadoop 2x architecture. So 1x architecture, what are the drawbacks we have noted here? Those drawbacks Hadoop 2x resolved or not. So those things we'll discuss in next session. Okay, so before going to Hadoop 2x architecture, here generally task tracker will execute and here your data it will write, right? Whatever content is there inside data file, that content who will write inside block. Okay, inside block who will write your data. So here we have two classes. One is a data streamer Java class, another one pipeline Java class. These two built-in Java classes, it will come with the Hadoop framework. Okay, so data streamer Java class, what it will do? Whenever task or tracker will start executing this data streamer Java class, it will write content inside the B1 block. Your data file contains some data, right? That data who will write inside block means data streamer Java class. Okay, but what is the purpose of pipeline Java class? Your only first copy data, first replication copy data, only your data streamer Java class will write, and the second replication and the third replication copies of data your pipeline streamer class will take care. Pipeline Java class will write second copy and third copy. Replication copies related data who will write means pipeline Java class, because all the three copies only data streamer has to write means it will take time, right? That's why only data streamer class first copy of the data it will write, remaining second and third copies of data pipeline Java class will take care. So internally other data nodes will interact each data node. So for example, first copy this 64 MB. So this data node 2, it will connect with the data node 1 B1 block and it will copy the data into B3 block. So second replication copy. Same way third replication copy. This is how about 1x architecture. Okay. Before starting 2x architecture, few things we want to understand about 1x related. So here in this slide, we are able to see 5 important nodes. That is, first one name node, second one secondary name node, and third one job tracker, and fourth one data node, and fifth one task tracker. So whenever Hadoop admin team want to install Hadoop software on top of Linux operating system, compulsory they have to set up these 5 nodes. Okay, so here Node means you can assume as a system or you can assume as a hard disk. So Hadoop perspective, always instead of calling system or a hard disk, we have to call here a node. Node means one system. So here all these five nodes, they have to configure Hadoop admin system. Okay. So who has to configure all these five nodes means Hadoop admin team has to configure all these five nodes in a cluster. So we have one concept here. What is a single node cluster and what is a multi-node cluster? So single node cluster means same mission. If it will work like name node, secondary name node, job tracker, data node, and a task tracker. So all these five processors are running in same mission means that is called a single node cluster. What is a multi-node cluster? Multi-node means each processor will run on different missions, like a name node separate mission, secondary name node separate mission, job tracker also separate mission. So each and every processor running on different nodes means that is called a multi-node cluster or fully distribution mode. So generally in Hadoop interviews, uh, they will ask like what is the difference between a single node cluster and a fully distribution mode. Okay, so we have to explain single node means all the five processors running in same mission means that is called a single node cluster. If all the processors are running on different missions, that is called a multi-node cluster or fully distribution mode. In all the real-time projects, generally they will use a multi-node cluster. But in a personal laptops or most of the training institutes or organizations, organization means educational institutes, they will use a single node cluster. So here in Hadoop 1x architecture, we discussed about block size, right? Okay. So 1x default block size 64 MB. This we discussed, okay? But we can increase up to 128 MB. Okay. So by default with the Hadoop software, it will come like 64 MB, but we can increase up to 128 MB. So even you can increase up to 90 MB also, but the max limit 128 MB only. And coming to 2x, Hadoop 2x, default block size 128 MB, but you can increase up to 1 GB. Okay, so this also sometimes in interviews they will ask, okay, what is the uh, block size in 1x and what is the block size in 2x and up to what level we can increase the block size. Okay, so this is about Hadoop 1x and 2x block size, and based on block size your split also Hadoop job tracker will take care, right? If block size is 128 MB means each split also your Hadoop framework will split into 128 MB only. And about the replication factor, we already discussed, right? Okay, so each block it will each copy of the data it will replicate into three different blocks. Okay, and about name node, we already discussed that it will store only metadata. Okay, but without consulting the name node, it is not possible to access the data files in HDFS. Okay, so if you want to access your data, compulsory first you have to approach only name node, because name node knows that where your data stored. So for reading purpose or writing purpose or delete purpose also, always each and every user has to consult only name node. Okay, so here five important nodes. This we already discussed. A name node only to store your metadata, and a secondary name node that is only for backup purpose. Whatever data is there in name node, same metadata always it will keep a backup in secondary name node. And data node, your actual data files, it will store inside data nodes. And coming to job tracker, so processing capabilities only job tracker having. And here all these five nodes, they divided into two categories. Okay, so master nodes and slave nodes. Master nodes, name node, secondary name node, job tracker. These three will call as master nodes. And task tracker and data node will call as slave nodes. And in this diagram, client means you can assume user, or I am the user, or I am the client. So I want to process some data, or I want to store my data. So processing capabilities, so who is having means only MapReduce having processing capabilities. And the storage capabilities, which component having means only HDFS component having process storage capabilities. So under MapReduce, job tracker will take care about the processing capabilities, and storage or space allocation name node and the secondary name node will take care. So all these three nodes will call as master nodes, and a number of data nodes and the task trackers will call as slaves nodes. So here if we see each and every job tracker and task tracker sending heartbeat signals, right? And even data node to name node also heartbeat signals going on. So heartbeat signals we already discussed. Okay, so whatever tasks job tracker will assign to task tracker, so that work task tracker has to complete, and again it has to give progress report back to the job tracker. And here also each and every data node has to send a block level report to a name node. And about the name node, so first point is name node is a master node, and the second point name node will call as a manager for a Hadoop architecture. And the third point, name node always it holds only metadata. Metadata means file name, file size, block ID, block size, file location, and the username, timestamp, date. So these all will come under metadata. And next point, for name node we need more RAM is required, right? Because it has to give fast response to each and every user or each and every data node. That's why more RAM is required for name node. Also in 1x we discussed, right, name node is the single point of failure for the Hadoop cluster. We have to wait until it is up. So we don't know when Hadoop admin will make it up. Okay, so this is one major drawback in Hadoop 1x architecture. So in maybe later slides we'll discuss about the 2x architecture. At the time we'll see whether this major drawback is resolved or not. Also here I have two data files. So foo.txt, bar.txt. So foo.txt name node assigned three blocks, and bar.txt name node assigned two blocks. So here I have three data nodes left side, another three data nodes right side. So you can assume this is a first rack 1 contains three data nodes, and the rack 2 contains another three data nodes. So 001 block, how many places it is replicated? So data node 1 copy is there, and here also 001, that means second copy is there. and the third copy it is there in a different rack and a different data node. So why third copy it is placed into different machine and a different rack means, if that copy also if we keep in the same rack, if this rack goes down means all three copies of the data it will impact. So that time it will be problem to access the data. That's why Hadoop framework always third copy of the data it will place in a different rack or different node or different data center or different location related server. Coming to secondary name node, so we know about secondary name node, it is just a backup purpose. So whatever metadata, latest metadata always available in a name node, same metadata, this FS image every 30 minutes it will send to secondary name node, so that the secondary name node will keep a backup. And coming to job tracker, so job tracker first point will call as master node, and who is having a processing capabilities means only job tracker having processing capabilities, that is called second point. And third point, always job tracker will coordinate with the task tracker. Okay, so what all are the tasks assigned to task tracker, those tasks completed or not, so that tracking also your job tracker will take care. And about data node we already discussed. Okay, so data node only your actual data it will store, and uh, data node always it will send a block level report to name node. So like what other blocks is full and what other blocks space is available, that information via heartbeat signals it will send to name node, so that the name node will update metadata information inside the name node. And the task tracker, we know task tracker generally will call as a slave node. Okay, so this slave node, whatever work a job tracker will assign, same work it will execute and it will give progress report back to the job tracker. Like if it is success message, if it is failure message, if it is still in progress means it will send like 20% progress or 30% progress, like that. Coming to Hadoop 2x architecture, in 1x architecture we have 4 5 drawbacks. Those 4 5 drawbacks in 2x there is a lot. So remaining all architecture everything same only. Okay, so first point here, if we see name node. Okay, so name node, Hadoop 1x we have only one name node, but in 2x we have multiple name nodes. So they introduced a multiple name nodes concept, but max number of name nodes you can keep in a cluster only 4 name nodes. Okay, but in real time projects they are using only 2 name nodes instead of 4 name nodes. They introduced multiple name nodes. Okay, so name node 1 and name node 2, name node 3 and name node 4. But here if we observe, all the data nodes are sending heartbeat signals to the name nodes. But who will give response back to the data nodes, or who will give response back to the users? Okay, that means out of 4 name nodes, one name node will be in active mode. Remaining all three will be in standby mode. So the active mode name node has to take care about responses. Okay, so now this active name node will take care everything. In case if this active name node goes down means immediately your name node 2 will up. So this will it will move from standby mode to active mode, and this will work like your first name node. So again, if second name node goes down, third. If third goes down, fourth. If fourth goes down, obviously your secondary name node available. So generally in real time, if one name node goes down means Hadoop admin team immediately resolve that issue immediately. Okay, so they will not wait till 4 name nodes goes down. Okay, so This is a name node issue, one major drawback in 1x architecture because single name node is there. So that issue they resolved in a 2x architecture. And coming to second point, Hadoop 1x, we have space wastage in a block, right? Instead of 64 MB file, if you keep only 30 MB file inside a block, the remaining space it will be waste, right? Okay. So in 2x, there is no space wastage. Even if you keep 30 MB file in one block, remaining space we can use for other files. You can store other files in the same block itself. So there is no space wastage in 2x architecture. Okay, so that is second point. So that issue also resolved in Hadoop 2x architecture. And coming to third point, Hadoop 1x for one cluster, it is allowing only 4,000 nodes. Okay, in server room, you can keep 4,000 nodes. So for one cluster, it will allow to configure only 4,000 nodes, but not more than 4,000 nodes. But in a 2x architecture, you can configure for one cluster n number of nodes, but they tested with only 10,000 nodes, but Apache software company is telling that it is supporting a number of nodes. Okay, so that is a third point. And coming to a fourth point. Okay, so fourth point, we have in the 1x architecture we have task tracker, right? Each and every data node contains one TT. TT means a task tracker, but in 2x that TT they renamed as NM. NM means a node manager. So task tracker they renamed as a node manager. So each and every data node contains here a node manager. Coming to fifth point, Hadoop 1x we have job tracker, right? So that job tracker here they renamed as a resource manager. Okay, so except these five changes, there is no difference between 1x and 2x. Okay, so when they released a Hadoop 2x in market, after that onwards only most of the MNC companies they started using a big data Hadoop, because when initially they released 1x, there are many issues and drawbacks in 1x. That's why most of the companies they haven't used big data Hadoop. But later, after releasing 2x, most of the companies started using a big data Hadoop. And here coming to Hadoop cluster. One cluster I have n number of racks, rack 1, rack 2, rack 3, rack 4, rack 5 like that. So rack 1, one name node remaining all data nodes. Rack 2, job tracker remaining all data nodes. And rack 3, secondary name node remaining all data nodes. And here remaining all the racks only data nodes. But here why they kept name node, job tracker, secondary name node on different racks? Why means these three nodes generally will call as master nodes. So if you keep all the master nodes in the same rack, if the track goes down means it will impact for all the master nodes, right? So that's why all the master nodes in real time Hadoop admin team they will configure in a different racks and different missions. So that is the meaning of this slide. In real time projects they will use only two name nodes. So instead of four name nodes, they will use only two name nodes. One is active name node, second one is standby name node. But all the data nodes will send a latest metadata via heartbeat signals to the all the name nodes. Okay, so if this name node goes down means immediately this standby name node will move to active mode and it will work like your first name node. Okay, here I have one server name node, secondary name node. Rack 1 contains three data nodes and rack 2 contains only two data nodes. So I have a data file here. You can assume this data file size is 94 MB. You can use a Hadoop command, or you can write a Java program, or you can write a SQL query. Using anything, if you try to store your data, it will split into two copies, right? In one X 64 MB first split and remaining second split. So 64 MB, how many places it is replicated? Data node 1, data node 2, and the third copy it is placed different rack and inside data node 4. Even if you see a blue color related two copies in rack 2, but third copy in a different rack. Coming to heartbeat signal, we discussed, right? Every 3 seconds, each and every task tracker has to send heartbeat signals to the job tracker. And the same time, data nodes also it has to send heartbeat signals to the name node. But task tracker to job tracker only progress report. But data node to name node block level report it will send. And now you can assume I have 5 nodes, but I have to configure like I have 5 systems. Which system has to work like name node and which system has to work like secondary name node. So, so that kind of configuration Hadoop admin team will take care. Okay, so by default with the Hadoop software, we'll get these XML files. So master.xml file. If you configure a specific mission related IP address inside this XML file, then that mission will work like a secondary name node. And we have one more XML, that is core-site.xml. So whatever mission related IP address you will specify inside this XML, so that mission will work like a name node. And slaves.xml, inside this XML file you can configure n number of IP addresses. Those n number of missions will work like data nodes. And we have one more XML file, that is mapred-site.xml file. So here if you configure specific mission related IP address, that mission will work like your a job tracker. So basically these configurations Hadoop admin team will take care for just knowledge purpose. I am explaining here. And the types of installation we already discussed, right? About a single node cluster and a multi-node cluster. Also, your Hadoop it will support to store your data. That means write operations it will support, and read operations also it will support, and delete operations also it will support. Okay, and in HDFS model, all the configurations, if you want to do any kind of configurations, backend we have one XML file that is called HDFS-site.xml file. Inside this XML file, you can configure your block size, you can configure replication factor, and you can configure heartbeat signals and trash interval also. Block size means default 64 MB. If you want, you can increase up to 128 MB in 1x. So that here value is there, right? Here they will change. And replication also by default 3. But instead of 3, if you want to increase up to 10 or 7, you can change that value here. And also heartbeat signal by default 3, but you can increase a 4 or 5 or 6. Okay, so these configurations generally admin team will take care. Okay, but just for knowledge purpose I am explaining here. Okay, and we have block level report. So block level report, we know each and every data node will send block level report to the name node. And a safe mode, okay, this is one important point. A safe mode, generally, for example, you have one Java server. If you start that server to up that server, it will take 1 minute or 2 minutes time, right? So same way in a Hadoop also, if you start a Hadoop server to up that Hadoop server, it will take some time, 1 minute or 2 minutes. In that 1 or 2 minutes, your Hadoop server will be in a safe mode. If server is there in safe mode means it will allow only read operations. Once a server will come out from safe mode to normal mode, then it will allow write operations, read operations, and delete. All these three operations it will allow. Okay, so here I have given some Hadoop comments to check a safe mode status. Maybe once I will start practicals, I will explain how to check server is there in safe mode or not. That I will explain later. And the next concept, types of scaling. Okay, so we have two types of scaling: horizontal scaling and vertical scaling. Horizontal scaling means, for example, you have only 10 machines. Those 10 machines almost data is full. So what you have to do, whether you have to buy new machines or you have to increase existing machines capacity. Okay, so if you add new machines into the cluster, means that is a horizontal scaling. Okay, but instead of buying new machines, existing machines itself, if you increase the capacity, that is called vertical scaling. Here we are going to install Cloudera Kickstart VM. Okay, so whoever want to do practice in personal laptops, you people can do same setup. So all the installation related links I will provide in the description section. Okay, so Hadoop software installation, main we are going to install only Cloudera Kickstart VM installation. So in this, generally we have to install 5 softwares. One is we need Putty, and the second one WinSCP or FileZilla we have to download. Third one VM player or workstation we have to download, and fourth one Cloudera start. So now we'll install one by one now. Okay, so here first we need Putty. So Putty I will install. So here download, and here we can see you can download Putty here, right? So once you go there, here we have tar file. So whether you can download installer or you can download a tar file also. Okay, so I'm installing a tar file. So tar file successfully are downloaded. So here I have Putty. And next software WinSCP. So WinSCP also we can download. Okay, so here WinSCP download. Okay, so downloads. So here you just go down, and here download WinSCP. Okay, so here it is downloading. Okay, so coming to next one, VM player or workstation. So here VM player, download. Okay, download VM workstation player. So here I'm just downloading latest VM player. So here we have download option. Download now. So this also started downloading. Okay, so this one also downloaded. So now last one, Cloudera Quickstart VM. Okay, so this one I have one uh, download link. Okay, so using that link we have to download. Okay, so this is the uh, download link. Okay, so what we have to do here, directly we have to enter that URL in a Chrome or your browser. Okay, and then click, automatically it will start downloading. Okay, So here it is downloading. Okay, so generally it will take some time for downloading because of 5.4 GB size. Okay, so we have successfully copied all the softwares in one folder. Now we'll install one by one. So first we'll install putty. Okay, now I'm installing putty. Just we have to click next and then install. Yeah, so we have successfully installed putty. Okay, and next we'll see how to install a WinSCP. Okay, so here we have a WinSCP. Just we have to double click yes button. Okay, so successfully installed WinSCP also. Next we'll install VM player. Okay, so we have to click next buttons. Click next button and then install. So VM workstation installation also successfully completed. Okay, now Cloudera. Okay, so this one already zip file, so just we have to unzip. Okay, we have to unzip, so extract all. Yeah, so we have unzipped the Cloudera Kickstart VM. Okay, now we'll set up Cloudera Kickstart VM. Okay, so here first we have to open VM player. Okay, we installed VM player, right? That we have to open. Okay, so for free for non-commercial. Okay, so time being we'll use a free only and then finish. Okay, so VM player we open. So inside this VM player we have to open that Cloudera Quickstart unzip file. Okay, so here open virtual machine or create new virtual machine. So we have to select open virtual machine. Okay, so go to that particular folder. So here this is the unzip file. So go inside this and again inside this and select this one. Okay, so but here for Quickstart VM we have to this for Cloudera Quickstart VM we have to give minimum 6 GB RAM. Okay, even some laptops if you give 6 GB RAM it will be very slow. Generally 8 GB we have to give. So here I will give 8 GB. Okay, go here and just here we can increase 4 to 8 GB. Okay, 4 to 8 GB. And number of processors also, instead of one I'm selecting two processors and then click OK. Okay, now here play virtual machine. We have to click play virtual machine. So who all are doing setup first time, so this will take 2-3 minutes time. So Cloudera Kickstart VM successfully opened. Okay, so basically here inside this VM we have Linux operating system. On top of Linux operating system, all the Hadoop related softwares installed. Okay, so now how to access this VM, how to access this Hadoop cluster from our laptop. Okay, so for that first we should know this particular mission related IP address. So open in terminal. So here we have to execute a Linux command. Okay, so this is the IP address for this particular VM. Okay, so let me copy that IP address. So I copied that IP address. So here I'm opening a putty in our local laptop. So I'm entering here IP address. So this is the IP address I'm saving. I'm saving as a Cloudera. Okay, so now just I'm opening. So now what I'm doing basically from my Windows machine to Cloudera or Hadoop software I'm connecting. Okay, so I accept. So here username and password we have to give. So username Cloudera and password also Cloudera. Okay, so successfully I connected Cloudera. So from here you can execute your Hadoop commands or all Hadoop related code you can execute here. Okay, so this is about Hadoop software installation. Discuss about Hadoop commands. So in our first module, HDFS module, we have practicals. So we'll discuss about HDFS module commands. So here we have different types of commands like almost 20 to 25 commands. So regularly we have to use only those commands in a real time. First of all, we should know what is your local path and what is your HDFS path. Okay, so in Cloudera, this is my local path, so Linux path, and this is my HDFS path, so Hadoop Distributed File System path. So basically, this HDFS path in real time, maybe your project manager or tech lead or a Hadoop admin team, they will provide. Okay, so they will confirm that which path is your HDFS path. Okay, so now here ls, so I have few data files in a local file system. So in this folder I have few data files. So cd data ls. So these are the different types of files. So these are all the files available in a local file system. So these are all available in my Linux operating system. Okay. Now I want to check what all are the data files available in HDFS path. So for that we have to enter a Hadoop command. So Hadoop fs -ls /user /Cloudera, because user Cloudera is my HDFS path. So if I want to see the files, then compulsory I have to enter ls command. So before ls hyphen we have to give, and Hadoop space fs, this is static. So whenever you want to execute any type of Hadoop commands, so compulsory we have to give Hadoop space fs. Okay, if your command starting with the Hadoop means that is a Hadoop command, always it will look inside your HDFS path. If you are not giving a Hadoop fs, if you are giving directly ls means it is Linux command, not a Hadoop command. Okay, so now we know, right, which one is Linux command and which one is a Hadoop command. If it is starts with the Hadoop means Hadoop command. If you're starting directly ls or a cp or something means that is your local file system command, Linux command. Okay, now we'll see what are the files available under user Cloudera. So it will display all the available files and the directories also. So it is showing empty. So that means there is no files under that directory. Okay. So now we'll copy one file. Okay. So how to copy a file from local file system to HDFS file system. Okay. So now I want to copy a file from local file system to HDFS file system. So Hadoop FS hyphen copy from local. So here F and L capital letters. Okay, case sensitive. And then your local file system path. So local file path, and then your destination path. Okay, or else you can like a source path and a destination path. Destination path. So source path always your a local file system path. Destination path your HDFS path. Okay. So now here I'm choosing one data file. So this is my data file employee.txt. So this file I want to copy from local file system to HDFS file system. So Hadoop FS hyphen copy from local. Okay. So I am copying from local to HDFS. So this is the command copy from local. Then your local file system path. So my file is there under home Cloudera, under Cloudera data directory, under data file name employee.txt. Okay, so my file available under home Cloudera data directory. Now HDFS path. So that means destination path. So user Cloudera. So I'm copying file. Okay, so I executed my command. So that means now your entire Hadoop architecture will execute backend. But here for us within 2-3 seconds results are showing, right? So now we have to check under that particular path file is copied or not. So how to check? So Hadoop fs hyphen ls user slash Cloudera. So under this path file copied or not. Okay, so file it is showing, so successfully copied. So whenever we want to check file existed or not, that time we have to use this command hadoop fs -ls, then your hdfs path. Okay, so file it is showing successfully copied. Okay, here I used copy from local, right? So instead of copy from local, even we can use one more command. We have similar command, that is a put command. Okay, so we'll see that later. So before that I want to create one directory inside HDFS file system. Okay, so Hadoop fs hyphen mkdir. So whenever you want to create a directory inside HDFS, you have to use mkdir user Cloudera and then directory name. So new directory name we have to give here. Okay, so a new directory name I'm just giving here RR digital. Okay, enter. So successfully created a directory. Now we have to check, right, a directory created or not. So Hadoop fs hyphen ls user Cloudera. So under Cloudera it should show RR digital directory. Okay, so here it is showing a new directory. That means we have successfully created a new directory. Now I want to copy a file from local file system to under this RR digital directory. So RR digital in HDFS, right? So now what I will do, instead of copy from local, I will use a put command. Okay, to copy a file from local to HDFS, you can use copy from local, or else you can use a put command also. Okay, so HDFS path RR digital. Okay, under this it will copy your data file. Okay, now we'll cross verify it is successfully copied or not. Okay, here it is showing so successfully copied. Okay, now I want to see what is there inside employee.txt file. So I want to see the content. So how to see the content? Okay, so for that we have to use cat command. Okay, instead of ls we have to use here cat command. Okay, so this is the data available inside that particular employee.txt file. Okay, now how to copy a file from one location to another location. So before that I want to remove this particular file. So how to remove a file from HDFS directory. Okay, so here we have to give -rm space -r so that it will remove your employee.txt file. Okay, successfully deleted, but we have to cross verify, right? Under the directory that particular file is there or not, we have to cross verify. Now how to copy a file from HDFS to HDFS? Okay, so maybe I have data file in one directory, same data file I want to copy to different directory. Okay, so how to copy? So here I have data file, so we have to use cp command, then data file available here, user cloud array employee.txt, same data file I want to copy under RR digital. Okay, so whenever you want to copy a file from one directory to another directory in HDFS, compulsory we have to use a cp command. Okay, now we'll cross verify under RR digital file is available or not. So it is showing file, that means successfully copied. Now I will remove again this file. Okay, I will remove. How to move a file from one location to another location? See, earlier we done copy. Copy means it will keep current directories one copy and a new directory another copy, same similar copy. But move means it will cut and it will paste in a new directory. Okay, so here instead of cp we have to use mv command. So now we'll cross verify. First under user cloud array employee.txt it is removed or not, that we'll check first. Okay, it is removed from this directory or not. So only one directory is there, there is no file under this directory, that means it is that particular file is removed here, and under new directory that file copied or not. Okay, so here it is copied, that means under user cloudera it is removed, and under user cloudera or digital directory it is copied, that means cut and paste happens. So whenever we'll use mv command, move command, it will do cut and paste. Okay, so now we'll discuss about the file permissions. Okay, permissions. So how to give full permissions? Here if you see read write and read. Okay, now I want to give full permissions. Okay, so here chmod 777 chmod 777 and then your file name. So we'll cross verify full permissions applied or not. Okay, so full permissions applied. So earlier this is the permissions, but now after applying this is a read, write, execute all. Okay, now I want to copy a file from HDFS to local file system. Earlier we discussed the local to HDFS, but now HDFS to local file system. Okay, so local, now we are in which directory? In Linux home Cloudera data. Okay, so moving, I'm going back one path back. So now I am under home Cloudera. So there is no employee.txt file. So now we'll try how to copy a file from HDFS to a local file system. Okay, so Hadoop hyphen copy to a local, here T and L capital letters, and then so HDFS to local means first you have to give HDFS path. Okay, so user Cloudera RR digital under this employee.txt, then destination your local path. So home Cloudera. We'll cross verify it is copied successfully in local or not. Okay, so here it is showing that means successfully copied. Okay, so similar way we have one more command. Even you can use copy from local, or you can use even get command also. Okay, so both will work to copy from HDFS to a local file system. I want to check server is there in safe mode or not. Okay, so when we discussed about Hadoop architecture, that time I explained about the safe mode, right? So how to check a server is there in which mode? So for that, Hadoop DFS admin hyphen safe mode get. If we give get means it will get the status of the server. Okay, so safe mode is off. Off means you can delete a file or you can copy a file. Okay, so read, write, delete all the operations. So till now we executed all these three operations because server is not in safe mode. Okay, so now for example you can assume Hadoop admin team uh, want to do some maintenance work. Okay, at the time even they can move server forcefully into safe mode. Okay, so enter means it will move to safe mode. See, safe mode is on. Okay, if safe mode is on means it will allow only read operations. It will not allow you to copy any data files. Even now, write operations also not possible. Delete operations also not possible. Only read operations. If server is there in safe mode means only read. You can read the data files, but not possible to store or delete. Okay, now again I want to move it from safe mode to a normal mode. Then you can enter leave command. So now safe mode is off. Safe mode is off means you can use the read command or write command or delete command. Okay, so previously we have seen how to read, how to delete a file from HDFS. Now how to delete a directory from HDFS, that we'll see. Okay, okay, first we'll delete a file, then we'll delete a directory. Okay, so successfully deleted. Now I will remove directory also. So to remove directory we have to use here command rmr. Okay, successfully deleted. If you want you can cross verify Hadoop fs hyphen ls user Cloudera. Okay, under Cloudera are digital available or not available. Okay, so successfully deleted. So these all are the commands are regularly will use in real-time projects. So we have completed HDFS model. Thanks for watching this session.